charities, etc. Okay, so that we don't have two people using the same user. Okay, so just go to the Google Doc and start filling in which one you're going to use. Okay, there's Larry's, put one in. Don't change the password column because those passwords are correct. Okay, just choose which one you want to use. If you like the number 21, go put your name there. Ivan is choosing one, okay, etc. Because before we get into the analysis of the bacterial genomic data today, I want to get you used to working with remote computers. But first, let's get everybody allocating themselves to a user. Solar, let's see. And once you've done that, you can just choose anything, just so long as it's right in the last page. Just choose anything, so long as you don't end up writing at the same time as somebody else. Okay? And then when you choose something, you're going to be, let's say, for instance, Stanislas is user 28, and that's Stanislas' password, okay? Obviously, we're all seeing each other's passwords, but let's not stomp on each other's users. Yeah. What is it? Okay, you can't type. Demand the request edit. Not everybody has edit. So I thought the students had edit access.
Tony,
Yeah.
can I make this document not to require specific access? Can I make this document accessible?
They should have access to.
People always are having multiple Google accounts and things. So.
Oh, okay.
So can you just?
Tony, I can do it. I'm asking you to document.
Yeah, sure.
Yeah. Okay, we just fixing it. Just reload the document. Just give us 1 minute to do that. Okay. How many are you? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, 15, 20, 14. Yes. That's fine.
It's not about access.
Yeah, so the Tracy's changing the setting, and then once the setting has been changed, once you change the setting, then we'll just reload the document, and then you should have access.
You also don't have access. You got access. Okay, you don't have access as well.
But it will all be fixed once we reload.
Okay, you can refresh now.
Okay, refresh the document.
Yeah, top.
Does it work?
Do you have access now when you reload?
Can you reload again?
No, yeah, they have always had access. So I mean, I don't know why.
I think the issue is that
Edit.
I think you probably gave access by their email addresses, right?
Yeah.
And some people have more than one
It's working now.
account, and then their stuff gets confused.
You have access? Yeah, she still doesn't have access. So.
Have you reloaded?
Yeah,
Can you share your cookies?
Just reload one more time.
You also don't have access.
It doesn't have that message anymore, so I think you do have. Just go down all the way to the bottom.
Can you edit now?
Okay, so try edit. It's working now, yeah.
Okay.
Okay, so I think everybody's getting. So let me start talking. I think everybody's getting access because look, we are fewer than we used to be, so that's why we're not filling in all of the cells. Find the master thing. So in this computer that I'm using today, it can run out of memory quite easily, so I have to just be careful here. So I've added an extra section in the section on introduction to Linux. Just trying to see where my mouse has gone. It used to be easier to do this when the screen was. No, but the mirror view, then when I'm trying to work here, and it makes my life more complicated as well.
Is your screen set to left and right, or top and bottom?
Left and right.
So then it's probably.
But no, my mouse is. Let me bring it back here. It's just that the screen is big and the mouse is small. There's my mouse. Okay. Sorry. And then we go introduction to Linux. Screen is big and mouse is small, so I must just go up there. There it is. Intro to Linux. And I've added a new section on working with remote computers. Okay. But before I talk about working with remote computers, first I want to talk about high-performance computing. Okay. So, in the past, I've asked people who's got a cluster at their home institution. Okay. But before we get into that, I just want to make sure that everybody understands the elements of computing performance. So, what is it that makes a computer powerful or strong versus making it weak? Okay. And those elements are basically 5, okay? Just go here and make the screen bigger. I'm going to change the screen resolution because the older monitors used to be big, but now with the high resolution, okay? So the first element is disk storage, okay? So how much disk storage do we have available? Okay, so now that this storage is typically in the hundreds of gigabytes or terabytes. Maybe let me start by looking at your laptops. At my laptop, your laptop, all of our laptops. Okay, so disk storage is coming in 2 types these days. Okay, so it's got the SSDs and what we call the spinning disk, the magnetic disk. Okay, magnetic disks typically 1 terabyte, 2 terabytes, so on. Your SSD is typically 256 gigabytes, 512, 1 terabyte, that kind of size, okay? But that's the amount of, you can think of that disk storage as being like a filing cabinet which is in a corner of your office, okay? It's big, but not easy to access quickly. So when people say that like they've got computing limitations, sometimes they mean disk storage, because when we start sequencing organisms, okay, so a typical bacterial sample is in the hundreds to about half a gigabyte per sample, the FAST-Q. The FAST-5 that we get off a nanopore sequencer is about 10 times that size, okay? So several gigabytes per sample. If we take a full-sized plasmodium sample, then we typically, I haven't worked them a lot, but my understanding is that they're about 1 gigabyte per sample. Okay. So if you've got a 200 gigabyte hard drive, you start using it up fast. So the first thing is, how much disk storage do you have? So then the second one is, how much memory do you have? And now, people who are not very familiar with computers, they get memory and disk storage mixed up. If you ask them how much memory you've got, they say 256 gigs of RAM. No, you do not have 256 gigs of memory on your laptop. Memory, otherwise known as RAM, random access memory, is like the space that you've got on your desk nearby, where if you get a paper from the filing cabinet and you put it on your desk, you can access it quickly. So it's the fast memory that is immediately accessible for the CPU, which we'll get to in a second, to do its work. But when the computer switches off, it's gone. Okay, so it's not permanent storage, and it's much smaller. So typically, on our laptops, we're talking about 4 gigs, 8 gigs, 16 gigs. You know, if you've got a power laptop, some people here seem to have some pretty powerful laptops, 24, maybe even 32, okay? But that's about where you end with a PC or a laptop, okay? On your server, you might have more, 64, 128, etc. Okay, so that is your RAM. Then you've got the CPU, okay, the calculator inside the computer, and these calculators, these days, we hear about cores, because what's inside the CPU is that one chip will have multiple CPUs inside of it, okay? So we hear about a 4-core or 8-core or more than that cores on a CPU. If we're looking at our servers, sometimes we're hearing 48 cores on one CPU. I'll get to what that means just now. And then, as we discussed, when George was having problems with his Conda, the CPU has its own binary language, which we call instruction set, and we normally differentiate between the x86 instruction set, which your AMD and your Intel CPUs have, and then the ARM instruction set, which M1 and chips and cell phones tend to be using ARM. Okay. The fourth element is network. Okay. So again, here network, we have to distinguish between different types of network. So here, within the building, we have what's called a local area network. Okay. So the local area network allows you to connect on the Wi-Fi or on a cable connection, maybe connecting into the wall. And typically the speed here is in the hundreds of megabits to gigabit speed. Okay, so if you are connected on the Wi-Fi here at Sanby, your connection within the building is several hundred megabits per second. Okay, now a thing to make a note of here is that when you're talking about network speeds, we talk about megabits. When we're talking about how big data is, we're talking about bytes. So for instance, if a file is 1 gigabyte, you must multiply the number by 8 to know how many bits it is. Okay? So 1 gigabyte file is about 8 gigabits. Okay? So that means that if you are able to move at 1 gigabit a second, if your network is 1 gigabit a second, how long does it take you to move a 1 gigabyte file across that network? If you've got no interruptions, complete use of the network. Remember that one byte is 8 bits. So your file is 8 times bigger in bits than it is in bytes. And you can move, and it's a 1 gigabyte file, and your network speed is 1 gigabit a second. So what did I say that file size was in bits? So how long will it take to move that file across a network that can move 1 gigabit every second? It'll take 8 seconds, okay? So, and that is if everything is perfect. But it almost never is, because the network has to do a whole lot of work to manage sending files. So it's to check, has the file got there yet? There's a whole lot of what's called protocol involved, okay? And the other thing is, I'm not the only one using the network. So if I took over the whole network, okay, and then sometimes I can't even load one page, you know, because I've used the whole network. So the network, you know, has to accommodate multiple users. And that's within your local area network. You have your local speed, but then our institutions are connected to each other using wide area networking, okay? So the so-called WAN, wide area network, so where all of our connections, so if you go into a data room of, here by our side, we've got a data room, we've got lots of cables going in here, because we have many different connections for the local area network. But that all goes down to generally a single or 1 or 2 connections between UWC and somebody else. Literally, there is one cable, okay? Maybe two cables, okay? If you go to your network hub of your institute, you'll find that. And that thing's speed is often a lot lower than we have here within the building, okay? So then we're talking about speeds in the, maybe you've got 10 megabit speed, not gigabit, 10 megabit, 100 megabit, you know, we're lucky here in South Africa, between our universities, we have 10 gigabit connections between the universities, but many people have much slower connections like this, okay? Like I remember some years ago, I was at an institution, well, in fact, more than a decade ago, we used to have two megabits here for Sanbi, the whole of Sanbi, okay? And then we moved to 20 megabits, and it felt like great because, you know, things were so much faster. But I remember visiting an institution that had, only a few years ago, had a 2 megabit connection, okay? And 2 megabits, so if you think that 1 gigabyte will move in 8 seconds across a full, like, 1 gigabit connection. If you've got 2 megabits, okay, and imagine you've got the complete 2 megabits to yourself, then that 1 gigabit file will take 500 times longer to move across a 2 megabit connection. So now 500 times 8. But when you've got a slow connection like that, everything piles up. It's like a traffic jam, okay? I've never had the pleasure of being to Lagos, but I believe their traffic jams are quite legendary in terms of moving around, okay? Because as things slow down, then everybody wants to move their data, and they inevitably end up crashing with each other, and then you don't actually get the full data connection, okay? Which can actually lead to a worse problem. We don't send data as like one file at a time. All the data that we send across the network gets broken into chunks called packets, okay? When you and you and you and you all want to send data at the same time, it all gets into what's called a queue inside your networking equipment. And if the data waits too long to send, okay, the networking equipment will assume that the data has been lost because it doesn't know, maybe there was a break or something like that. And it will then resend the data. So then what you end up is what's called packet drops, so where one of the packets goes missing, and then the networking equipment will try and send that data a second time. And when that starts happening, then like everything slows down because now you're actually sending the same data more than once, okay? So that's networking. And then finally, accelerators, okay? So, just get my mouse to the right place. So accelerators, by accelerators, I mean things like the GPU cards that we often use for things like base calling, Oxford Nanopore data. Who here has a gridiron, a Nanopore gridiron at the institution? I know some people have gridirons, yeah, okay? So, and have you ever used the gridiron for anything besides base calling Nanopore data? Because you know that inside a gridiron, there's a V100, NVIDIA V100 accelerator card that can actually be used for other bioinformatics tasks. Because inside a gridiron, it's actually a Linux machine running Ubuntu, you know. So, but accelerators, we're most familiar with GPU cards for base calling Nanopore data, but so if who here has got a Mark 1C, a Nanopore Mark 1C? Yeah? And that's got a so that's got a GPU card built in, but it's quite a slow GPU card compared to like you know, the ones that you can, like RTX 3080s and all of those kind of things, okay? So the you know, but still, the GPUs can be used for more than just Nanopore work. There's other, like for instance, they're a big deal in the world of machine learning and artificial intelligence because they get used to train machine learning models. But anyway, so each of these aspects of strength of a computer can have its own problems. Okay, so as I described, running out of disk space, you've got no way to store data anymore because you don't have enough hard drive space. Okay, then when you run out of RAM, if your computer doesn't have enough RAM, then what you'll see is that when you're running things in the computer, everything will freeze up. Okay, because the RAM is there's a process inside the computer that's trying to always find space for things, and if it doesn't find enough space in the RAM, it will use the disk to try and move some things from RAM to disk. But the disk is so much slower than the RAM. The result is your computer will freeze. Okay, having used this laptop again for a few days, I've become very familiar with things freezing up. Okay, and then maybe if you're lucky, the computer will notice which program is using the most RAM and kill that program, and then your computer will come back. Okay, but so if you don't have enough RAM, you just can't do enough analysis work. It just stops certain, like some analysis that I want to do on this computer, I just can't run because this computer has 8 gigs of RAM and the analysis needed 6 gigs just by itself. Okay, and the other things that were running in the computer didn't give 6 gigs of free RAM and things crashed. Okay, so and then the next thing is CPUs. Okay, so CPUs have been getting faster, but not very much faster. Okay, so if you look at how much CPUs in the last 10 years have increased in speed, they haven't increased a lot. It's just a slow curve of increased performance. What's happened is that we now get a lot more CPUs. 10 years ago, our computers would have one CPU. Now we have, many CPU cores, okay? But that is only going to help if your computing analysis is set up in a way that is going to make use of it, okay? So luckily for us in bioinformatics, a lot of what we do is running the same thing multiple times. So you've got an analysis pipeline. Now I've got 5 samples and I want to run each sample at the same time, okay? And then it will run 5 copies of the pipeline, okay? But if you've got something like, a good example is phylogenetics. If you've got a big phylogenetic analysis, then it's much more difficult to actually use more than one CPU core. So you'll see this one thing running for a long time on one CPU, and having more CPUs doesn't help. So especially if you're using a tool like Beast for Bayesian phylogenetics, but phylogenetics in general doesn't parallelize very well. So you have to know how does your workload relate to CPUs, okay? And then when we don't have enough CPUs or RAM on the one computer, that's when we start expanding into multiple computers. Then we start talking about computer clusters. So generally, your migration pattern goes from either a PC, either a personal computer, a laptop or a desktop. When that is not big enough, then you can obviously expand the laptop or the desktop. You can get a more powerful one with more RAM and things like that. Then people tend to buy a server, okay? So either the tower server that's sitting on a desk or the rack-mounted servers that's sitting in racks, okay? And those are designed to allow you to have more CPU cores, more RAM, more disk space. So then people have a server. Then the next thing that happens, when the one server is not enough power, then people will buy like a few more servers. And normally, if they're doing this thing just based on when they get money, then things start getting complicated because now you have 3 servers and you might move between the different servers for whichever one's got free resources, right? So that's how we used to be at Sanby about 20 years ago. Servers had names, you'd choose whether you're running things on Ziggy or whether you're running things on Techno or whatever, okay? and you'd see who's got which server has space, and each one was set up slightly differently, and so on and so forth. So then, when you go beyond that level, then you have shared disks between all the different servers. You have schedulers that basically allocate computing to wherever there's free CPUs, and that's called a cluster, okay? But building a cluster, so running a PC, looking after your PC, most people have been trained, this is how to look after things on a PC. Yes, things can still get like not installed the best way, but yeah. But it's generally people know how to look after a PC. Looking after a server, you can think of it like a big PC to some extent. But then when you start looking after more and more computers, you need the skills to be able to design a proper computing environment, automate the installation of software, because you don't want to remember how you installed software. You want to have a script that installed the software for you so that each computer is the same, etc. Okay? And that's where we're moving into the world of high-performance computing. And then finally, in your high-performance computing world, then you might also incorporate, because incorporate accelerators like GPUs and things like that. So that you can do base calling maybe on your cluster instead of doing base calling on a like maybe a laptop and then moving the data to cluster. Because a lot of people, they start off in a world where like they've got the GPU is on a PC because it's like a PC piece of hardware, and then they will copy the data across the cluster for further analysis. But if you because the GPUs in the servers can actually be very expensive, you know. If you buy for instance, a RTX 3080 GPU is I don't have it in dollar terms, but it's about 30,000 Rand these days, okay? So just remember the 30,000. But if you're going to buy a V100, it's 200,000 Rand. Well, I mean, they're now A100 and things like that. I mean, so that they're 10 times more expensive, the server class GPUs, than the PC class ones, okay? So, actually, I forgot I was going to give everybody a task to run while we do the other things. Okay, so this is because we're thinking about this high performance computing world, we have to think about working beyond our PCs, connecting to computers that are not remotely and moving data around. Okay, but I just remembered at this point that I forgot that I want you guys to start installing the next piece of software now so that we have that ready by the time we get to it, okay? So, by now, so just pausing this, by now everybody should have a shell set up on their computer with conda, right? Do you all have okay, I'm just going to change my display settings. This is crazy. The resolution is nuts. I'll pass back here. This one. So this one was on 1920. Let's put this one on 1920 as well. 19. Okay, now at least I can vaguely see what's going on here. Okay. So, when you open a terminal, everybody should have something like this, where I'm just going to make this bigger.
Sorry, Peter. International link to access the Sunday chat.
No, we're not getting there yet. Just wait with that. Sorry, I meant to actually start this at the start because we're going to be using the Bactopia software later, okay? But to make sure that we've all got Bactopia, we need to install it, okay? So, when you installed Conda the other day, George, did you get them to install the BioConda BioConda as well? Okay.
Yes, we set up. Let me know if anyone has a challenge.
I already have Conda. Already have Bactopia installed, but this is the command that I want everybody to be using. Okay. So, Conda create space -n Bactopia, and then another space Bactopia. So the word Bactopia is used twice. Okay? And now we're going to need the sticky notes because I'm going to have to just check that this all starts working for everybody.
We're not sure if anybody managed to install the BioConda.
Conda, well, we are about to discover that. Okay? Because I'm going to need to do the whole pile of software setup today, but let's do it piece by piece, okay?
So should they run that?
Yeah, can everybody run this command? Okay? And when you run this command, I must just change something so that I just hang on. I need to delete my existing Bactopia. So when you run this command, then it will spin around like this for a while, collecting package metadata, and now it will freeze my computer. Oops. My computer is running out of RAM. That's what's going on. /. Okay. So after a while, it will give this long list of things that need to be installed. And then it will ask, do you want to proceed? Yes or no. Okay? So if you get to this, do you want to proceed? Put up, and then you can hit yes, and it will start installing. Put up a green sticky. If that's not working for you, put up a pink sticky, please.
If you're on a Mac,
If you're on a Mac, you're going to have to. If you're on a Mac, you're going to have to work with somebody else today because this won't work on a M1 Mac.
Somebody doesn't have Conda installed.
Okay, but then I'll come deal with Conda installation. So sorry for the M1 people, but yeah. Okay, so let me see what you've got going here. Okay, so we don't have Conda installed. Let me just check what's in your $sign. So there it is. That's $, right? Right? There, $. Let's first see what's in your home directory. So you've got it there, it's just not activated. Yeah, if you get if you get that message about packages not available from current channels. Okay. Okay, for the helpers. If you don't have the Conda where it says base, then it means that one of two things is happening. It means that either Conda is not installed, or more likely it's not activated. Okay? A lot of people have Conda, or some people have Conda installed but not activated. If you get a message that that Bactopia is not available from the current channels, go to the BioConda website and run those instructions on setting up channels. Okay? So what's happening here is that it's, I just want to see which is the correct one. It is installed, but it's just not activated. Okay? It's if you see there it is. So you must source, yeah, exactly. But can I just, yeah. So the mini forge. It's the mini forge one, right? No. I don't think it's in. I don't think she's got it in Bachelor C. Let's just see what's in Bachelor C first. Cat. Cat. Oh, it is there. Okay, so now we have it. Okay. Okay, so now we can try that Conda. Create minus and then Bactopia. Yeah, that's the one. Yeah, but it should get to the right place just now. We'll just give it a minute. What's so this is green. Are you coming green now? Is it coming right? Okay. And if it stalls, then you might not have enough round 3, but let's see what's happening. Okay, there. Wait. It's not in the right channels. Okay, so then we need to. Can you go to. Oh, but you're doing this thing on lesson. You mustn't do this on. You must do this on your computer, not on. So you must open a terminal, Windows terminal. Not PowerShell. No, not PowerShell. The do you have the terminal? Yeah. But it's still got PowerShell here. Do we not have WSL? But do you not have WSL installed here? I thought we installed it the other day. Was maybe that PowerShell. But we installed WSL. I remember doing it.
Yeah.
Maybe it's just not active. Let me just check. Sorry, XSL. See, there's Ubuntu. No, but that's 1804. Why is it not type? Okay, there. You see, WS. I'm so confused. Where is it gone? I definitely remember setting it up for you. Okay, let's do this way around. Sorry. Computer. Why is it not working for me? Why is it not finding PowerShell? So once you run as administrator, then it goes away again. Yeah. Maybe there's too many things open. Why does it keep closing the window here when I type? Why is it doing that? Just close some things here. Okay, I don't know what's going on here because it was set up the other day. I'm just going to close this as well. Maybe this. Let's just try something again. See if we get the right thing here. I wonder if it's logged in as a different user, maybe. WSL. Sorry, WS. But we installed it, we literally installed this on this computer. Where? It's like it's forgotten everything that we did the other day. I don't understand how. Okay, so okay, on your side is it installing? Yeah. Okay, it's just taking long. I'm just going to go on mine. So that, yeah, no, it's just trying to figure out because we installed WSL on this computer, but now it's gone. I'm sure that it was here last week. We installed WSL. I remember installing WSL on the computer, and we went through everything, and now it's not available. Okay.
I think it's good when we install Docker.
Yeah, but no, but Docker is a separate program from Windows. Yeah, it's not installed, and I installed it. So I'm feeling like I'm going crazy. Okay, let me try and go from zero and redo it. Okay. Let's check that I've got enough resources for this. No, I'm starting from scratch, as if I've never installed this thing before. So great. Okay. How's this one going? Is it installed and working? Okay, so I'm dealing with two installation problems here. Who is still having installation problems? Yeah. Okay, I've got this. I've seen this error before. Okay, but the problem is, I've had this error before. Yeah, but I think I've seen this error before, and it's related to like dependencies and things. Let's just see which kind of version we're on here, because it's what now is actually trying to. That is what so I search. I couldn't find a version when we update this content before, and solve everything one and two. So I did this in minor I wasn't worried. The other thing that is the cache seems to be. Let's try it. Oh, okay, we mustn't do it this way, right? We have to set the channel setup first. Yeah, we have to go to and we have to run this command to complete between this and the new version of Conda. Okay, so this one, I've installed WSL on my laptop and it was just gone when I went back to it. It's just gone. Is it? Oh, what? No. Okay, so now I've installed that. Haha! I just wanted to get that going because I knew that the installation takes a while. So now let's switch back to what I wanted to say about remote shell and things. Okay, so how are we doing for time? Coffee break is 10:30, right?
Yeah.
Okay.
20 minutes.
We got 20 minutes. Okay. So now, switching your brains back to, back away from Backtopia, okay? The next thing is, so I wanted to make, sorry, I've got in the order of things a little bit mixed up today, but who here has used SSH before to connect to another computer? SSH? Yeah? A few? Yeah? So SSH, I'm drawing on a lot of the materials from a project called HPC Carpentry that teaches people how to use high-performance computing clusters, okay? And SSH lets you do a secure connection to a remote machine, okay? And the reason that we want to do this is because often that remote machine has more power than our local computer. We'll do the installation let's just get a terminal open, but we'll do the Backtopia installation at coffee time. Okay? So we'll get there, okay? And the basic way that we use SSH, and SSH is available on Mac, it's available on Linux, apparently even available in Windows, but definitely with WSL is available in Windows, okay? Is that we're going to go SSH and then it's the username at and the name of the remote computer, okay? So this will connect over the network to our remote computer. And the extra S in SH is for secure. So it's doing encryption. It's encrypting the connection from your computer to remote computer, so nobody can steal data in the middle, okay? So can everybody please open a terminal, different one from where you installed Backtopia? I mean, if your Backtopia is still installing, don't interfere with that. And can everybody please open a terminal and then you've got usernames from that other list, okay? So if I'm at my terminal and my user, let me go find myself a user from the user list. So I'm going to take user 10. Why can I not type here now? Okay, and this is my password. So take your password from the password list, copy it, and go to your terminal, and now SSH user, mine is user 10, yours will be whatever number you've chosen from the list at shell.sanb.ac.za. Okay? Sorry, I just want to make it do the same thing because I've used this computer before, so I'm just going to just do a command. You can ignore this command I'm typing, but I just want to illustrate something. So when you do this, you will get this warning message. Okay? The authenticity of host shell.sanb.ac.za cannot be established. ED 25519 key fingerprint is this, okay? And this fingerprint is ZESWHH whatever, okay? The reason that you're getting this is because I said that SSH is encrypting your connection from your computer to the other computer. But how do I know that the other computer is who it says they are, okay? So if somebody wants to decrypt your connection, one way they can get at your data is that they can, if they can put another computer, if they can somehow hack the DNS network servers or something like that, and they can put another computer there which steals the name shell.sanb.ac.za, okay? Now you log into that computer, and then inside that computer, you know, somebody has kind of compromised something, right? So it gives you these fingerprints. And if you already have know somebody who's using that remote computer, like me, for instance, you can ask them, well, it tells me that the fingerprint is ZE, SWHH, etc. Is this the correct fingerprint? And then I can tell you, yes, that is the correct fingerprint. You are connecting to the correct computer, okay? So if somebody then, if you say, yes, I want to carry on connecting, then it connects you and it asks for the password, okay? Now you type in, or in my case, paste. I copied it, so now you paste the password that you had. Oops, I took too long to answer the question, so now it closed my connection. So now, next time around, it's not going to ask me the fingerprint question. I type my password, and now I'm on the remote computer, okay? So now I'm user 10 at lesson, okay? My shell prompt has changed to show that I'm on the remote computer. If I want to get out of here, then I can either type log out, or I can hit Control D. Okay, Control D does the same thing as log out. Okay, but you see the second time onwards, when I connect to the computer, it doesn't ask me to verify the fingerprint. Okay, the reason is because it has saved the name of the computer, cheryl.sanby.ac.za, along with that fingerprint. It has saved it onto my computer. Okay, which means that if somebody hacks that computer and changes something, like then it becomes, if somebody replaces that computer, then you will get an error message. This computer's fingerprint has changed. Okay. Not every kind of hack will give you the error message, but if somebody was to replace that computer, you would get a warning that this computer's fingerprint has changed. So it's remembering that I know about that computer. Okay. So when I'm connected to this remote computer, I can see that it's got different resources compared to my local computer. One of the things is that there's basically 32 gigs of RAM on that computer, on that remote computer, okay? Compared to like 8 or whatever you've got on your local computer, okay? So it is a bit bigger computer. One of the problems why I can't get everybody to use this computer together. So if I see where, if I say df minus h dot, how much free disk space is in my current directory, then you see that already 76% of this is used. Okay, so there's not a lot of storage space on this computer, right? So it's not, I'm not inviting you all to come bring all your data and do your analysis on the computer. It's just here for training purposes. But this is how we use SSH, okay, with the username and password, okay, to connect to a remote computer. And you must always pay attention to what your prompt is saying so that you know in this shell window which computer am I working on, okay? In the notes from HPC Carpentry, they talk about logging into remote computers using a key instead of using a password, okay? I'm not going to go through that today, but it is worth reading those sections and learning about it, because the problem, there's two problems with logging into a computer, a remote computer with a password. The first one is obviously that you have to remember the password, and some computer systems lock you out if you get the password wrong a few times, okay? But the other more fundamental problem is that if somebody has hacked that remote computer and you type in your password, then they can capture your password. So it's actually more secure to use the key-based logging in system. So how the key-based logging in system works is that you make a key on your computer, okay? You can read the instructions in the HPC Carpentry materials. You make a key, and that key has two parts, a private part and a public part. The private part you always keep, and the public part, then you put it on the remote computer. And then the remote computer can authenticate you because it checks the public part against your private part, and then you can log in, okay? So this is a secure way of doing things, but if you are going to do that, then remember that your two things. Your private key, it is you. Anybody who's got your private key, if I've got Stanislas's private key, I can log into any computer that he had authorized himself to, okay? Which means that it's like having his password. It's a very powerful thing. The other thing that I learned again for myself on the weekend is save your public key somewhere. Your private key somewhere. Save that private key somewhere, because what happens if your computer gets stolen? Now, all of those servers where you've got logins based on your on your key, you don't have access to anymore. Okay. But now, where should we save our private key? Okay. To a file on disk somewhere in Google Drive? No. save it to your key safe or password manager, okay? So who here is using a password manager for keeping track of their passwords? Only George. No. Also, you see, we have somebody, not only George, okay? And the rest of you, how do you even survive in this modern world? No, but that's as a password manager as well. So that's also a form of password manager, okay? So Google remembers your passwords for you, so long as, but it means that, but do you keep your bank password in the Google password thing? No. Actually, my bank password is the one I don't even keep in a password manager. I just keep in my head. But the thing is with Google is that it's fine for websites, okay? It doesn't solve the other problem. What password managers use, which one are you using?
I use the Google.
But okay, using the Google one. But so you're not using a separate one. So I use a thing called Bitwarden. Other people use LastPass. Other people use one password. I did a little poll amongst people yesterday, and I got like so many answers. KeepPass, so many things. I've given some examples on the training website, but a password manager lets you store all of your different types of private information. So with Bitwarden, I can store my website password, but I can also store my SSH private keys. I can make secure notes for myself that can store these things, and it gets synchronized between all my different devices. You know, I've got the app on my phone, I've got it in my web browsers, and so on and so forth, okay? And a password manager like that has the other advantage that they all come with a built-in password generator. So if you need a new password for a website or for a computer or something like that, you can get the password manager to generate and save one for you, which is much more secure than you trying to come up with a password yourself. Because humans are not very good at randomness, okay? And we tend to follow patterns when we make passwords. But if you ask a computer to make the password for you, it's more secure, right? And they don't have to be nonsensical gobbledygook, because, like, if you look at the passwords that we're using for logging in, you know, Bony Parrot Engine, chimp uncode possible, okay? They sound weird, but they are easier to remember than like random combinations of letters and numbers. But they are still quite secure, because like if we're making combinations of letters, you know, if we're making like letters, there's 26 letters in the Latin alphabet, right? But there's thousands of different types of different words. So if some computer's trying to guess a 3-word password, then finding exactly which 3 random words have been put together, it's quite difficult for a computer to do, okay? So, but for you to, you know, maybe it's not at first obvious, but it's not that difficult to remember Mayday, earwig, cultivate, okay? You can make a little sentence for yourself. On Mayday, the earwig cultivated some vegetables or something, okay? So passwords that are phrases are secure, and if you do need to remember them, are easier to remember than random, like kind of BZ3Q type passwords. Okay, so we're now able to log in with SSH. And that's fine if we want to run some computing stuff on the remote server. But the main thing that I want to get you doing is to move data, okay? Because I'm going to use that server to distribute data that we need for the later training today, okay? So, the tool that we're going to use is SCP, okay? So SCP is just like CP, but with an S, okay? For remote copying, okay? So now I'm able to log into my remote server, which means I can make a connection, which means I can now also copy. Okay, so just like the copy command, which has a source and a destination, SCP has source and destination, but one of them is a remote computer. Okay. So here's an example of an SCP command. Okay. SCP username at remote computer : file name dot. So let's look at the different parts of what we've got in an SCP command. Okay. Obviously we need to have the username and the name of the computer. So just like we said SSH username and the name of the remote computer, we have SCP and the username of the remote computer. But then we have a colon, okay? So what the colon means, that separates the computer name part and the username part from the file name part, okay? So then we're going to choose what we're going to copy, and then finally, I think we all know, what does dot mean?
Yeah.
Dot is the current directory. So we always have to have a source and a destination, right? So if we want to say where we're going to copy it to, copy from that computer to here, okay? But we can also do it the other way around. So, and there we do things slightly differently. Let me just find the right window. So here's a file called file.txt on my computer, okay? If I want to copy it to the remote computer, scp file.txt user10 at shell.sunbeam.ac.za : okay? Hopefully I've still got my... So notice that here, I didn't put anything after the colon, okay? So if I don't put anything after the colon with the SCP command, it means that it will go into my home directory on the remote computer, okay? And after the colon, I can use relative or absolute paths, okay? So I can, if I type that's a network error.
Yeah, compared to what she's.
That's interesting. I'll have a look at it in just a minute. So if I did this, then what kind of a path is this here at the end? Starts with a slash, so it's an absolute path, right? So now I'm saying copy this file to /home user12. When I try and log in, it will tell me that I don't have permission to do this, right? Permission denied, but because I'm not allowed to write to home user12. But if I did this command, what kind of a path is this? When I say documents here. Relative, yes. So this is relative, and I said colon by itself means a colon by itself means home directory. So all paths after colon are relative to the home directory. Okay. So what this means is that what is the path? It will be home user 10 documents. If I expand the whole path of where this is going to end up. Okay. So as an exercise, I would like you guys to fetch a file called message.txt. Each of you has in your home directory a file called message.txt. Fetch that file and see what's inside it. Okay? From your user. Let me come have a look at the network problem. Okay? So do this, and if this is working and you can look at the message, then put up a green sticky. But take all your green stickies down for now. If you can look at the message, put up a green sticky, okay? And if you cannot put up a red sticky, and then we're going to have a coffee break soon thereafter, okay?